Okay, let's get this show on the road. Hello, everyone. Hope you're well. Welcome to another edition of Math 1108. Hopefully, you guys are doing okay. Hopefully, you guys are present. One turns on their camera here. Okay, let's actually jump into it. Don't have a crazy amount to do today. Hold on. Where are we? OneNote. Okay, so let's see. Make sure I can see the chat. Okay, so we are going to start chapter 5. So last time we already looked at setting up systems of equations, linear equations, and solving them. Now we're going to start dealing with linear inequalities. So the main application or the main goal of chapter 5 is actually in section 5.3, where we're going to be doing linear programming. However, we need to kind of build up to that point. So we're going to start very slowly. We're going to start with the basics. I'm going to give you all the definitions. We're going to build up to the point where we can get that. But 5.1 and 5.2 is, for all intents and purposes, kind of prerequisite material in order to be able to do the stuff that we're interested in 5.3. So everything I'm going to teach you in 5.1 and 5.2, it's kind of like that's all just a part of the setup to start solving the problems in 5.3. So today's lesson isn't going to be that crazy or that difficult, at least hopefully not. Tomorrow's lesson just builds on that a little bit. No, not tomorrow. Friday's lesson just builds on that a little bit. But then immediately after that, we're going to go into section 5.3, and that's where the fun begins. For now, I'm just gonna go through just a lot of notes, making sure that we understand the terminology, we understand the concepts that we're dealing with, and how we can actually get things done. So I'm actually going to be writing for a little while, for the next 15 to 20 minutes or so. But follow along, and we'll get through it, and we'll get to some interesting stuff pretty soon. Once again, I am bit sleep deprived, so if I slur my words or whatever, don't mind me too much. So we are going to do linear inequalities. At the moment, we are only going to focus on 2-variable linear inequalities because we're going to want to be able to sketch it in 2 dimensions. Now, this is not a requirement in general to be able to do this. The things that we'll be doing in 5.3 can be done in multiple dimensions, and in applications today, they're literally done in thousands of dimensions. But for us to be able to do it by hand and draw pictures and stuff, we're going to stick to 2 dimensions. So I'll just mention that. I don't know why it does that. FYI. Okay, maybe that was, maybe I can do that. I'll have to figure that out later. I want to be able to change the pressure sensitivity on this pencil. FYI, we will stick to, I see how thick it drew the C. 2 variables, 2 dimensions. For now. But also remember, when eventually I'm going to teach you how to solve these things using Excel Solver and Python. So when we get there, we'll probably do some examples with more than 2 variables. But for us doing this by hand, we need to know how to do it with 2 variables. So for now, everything I'm going to tell you is going to basically be in relation to 2 variables. But you should have the appreciation that we can actually have many, many, many more variables here. Okay, so let's talk about the definition. Okay, a linear inequality. So I'm actually defining what the titular character of this arc. A linear inequality is an inequality of one of the forms. Okay, so anything that you can write in one of these forms is a linear inequality. Okay, so it'll be like ax plus by greater than c. Ax plus by greater than or equal to c. Ax plus b ax plus ax plus by. For some reason, I write very thick in this location. I think my table is uneven. Less than c. Ax plus by less than or equal to c. By the way, these guys up here, these guys are called strict inequalities, meaning they can't be equalities, right? They're strictly greater than or strictly less than. Right? So you should know that. And something that's important, especially as business majors, is that not only do we need to know what we're talking about, so we need to know our definitions and blah, 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 but we also need to sound like we know what we're talking about, right? So when you're like, oh, strict inequality, someone's like, hey, this person knows what they're talking about. You know, I should listen to this person. Okay, so that's very important, that for reasons that I'm sure your other classes will get into. But that's called a strict inequality. And of course, the ones below are not strict inequalities because they can be equalities. Here, x and y are variables. A, B, C are constants with A, B not both 0. Okay, that's it. So A, B, and C are numbers. Your x and y are the variables. You can't have both x and y being equal to 0. It's not considered a linear inequality. Okay, so that's it. That's what they are. Okay, now let's talk about solving them in the particular kind of way that we're going to want to solve them for our purposes. I guess maybe I'll tell you about the definition, what it means to solve them, and then I'll tell you how we want to solve them. So the solution of a linear inequality is the set of all coordinates or points, we call them pairs, x comma y, that make the inequality true. So if you take two x and y values and you plug into the inequality, it should be a true statement. So if you plug in x and y and it says something like 7 is greater than 2, then that's true. It means that the point that you plugged in is in the solution set of that linear inequality. On the flip side, if you plug in some x and y values and you end up with -3 is greater than 2. That's obviously not true, which means that point does not solve the inequality, right? But in general, you have a lot of solutions. In fact, infinitely many solutions to you'll have that for a linear inequality. But to know which points are in the solution, you can just plug them in and see, is it true, right? Now, of course, you don't want to plug in an infinite number of points, so we're going to think of a different way to actually find the solution. But yeah, so the solution lies in a region called a half space, a half plane. People call it half space as well. Half plane, because since if we sketch an inequality, it splits two-dimensional space, which we'd write as that, two space into two halves. They're infinite sized halves, but we consider them halves. And only one of these is the solution. Okay. Yeah, I'll tell you guys about that a little bit later. To let's say graph the solution, of a linear inequality. Okay, so I'm going to give you the super duper three-step method. So one, what you will actually do is you will actually first sketch the equation, right? So you're first going to actually sketch the line that is the equation, right? Now, I'll mention some things here. They're not actually a part of the steps, but they are things you should be aware of so that you don't waste your time. This is a line you need at most two points to sketch a line. Every now and then I'm in like a pre-calc class or something, and I'll see people like sketching lines, and they'll plot like 15 points to sketch a straight line. You only need 2, right? You're wasting a lot of time if you ever plot more than 2. A lot of times you don't even need 2, but at most, the most amount of points you need to plot any straight line is 2 points. The intercepts are often convenient points. Not always, but very often. Okay, so that's the first thing. First, just sketch the line. However, this has some rules. So in 2, how you sketch the line actually matters. If you have a strict inequality, So this means you have this or that, then the line should be broken. You should sketch a broken line. That is, you sketch it like with dashes. If you have greater than or equal to or less than or equal to, then the line should be solid. Right, so it's just like a solid line. 3. Now what you're going to do is, once you've actually made your sketch and you've done it according to the kind of inequality you have, you are going to determine the half plane that solves it. Determine how do we do this, Jhevon? Well, I'm glad you asked, proverbial student, whoever's in the room. We have 2 main ways to do this. So one is you can plug in a point, test a random point. What that basically means is pick a point and plug it into the inequality. Test a random point in one of the half planes. Right? If this point makes the inequality true, then that half plane is the solution. Shade it. If the inequality is not true, then the other half plane is the solution. So shade that one. So that's one way to do it. So you sketch the line. The line of it obviously is going to split 2-dimensional space into 2 parts. Pick a random point from one of these parts. You're going to plug in the x and y coordinate for that point into the inequality. If it makes sense, then the region in which that point came from is the solution. Shade the entire region. If it's not true, then it means the opposite region is the solution. Shade that one, right? That's basically what I'm saying here. So that's one way to go about it. Here is a second way to go about it. Rewrite the inequality by solving for X or Y and shade in the following way. Okay, so given that inequality, I can move stuff around the inequality just like an equal sign. Remember that? So the only difference is if you multiply both sides by a negative, you have to turn the sign around, and hopefully you remember all of that. But if you just move things so that you're not multiplying through by a negative, you don't have to worry about that. And so just move things from left to the right, and whatever side you want to solve on, either solve for the X or the Y. And based on how it looks when you have accomplished this, you can know where you want to shade. So for example, let's say you solve for the Y. Then you're going to get something that looks like one of four things. You're going to have Y is greater than some number times X plus a number. Or you'd have Y is greater than or equal to some number times X plus a number. Or you would get Y is less than some number times X plus some number, or Y is less than or equal to some number plus times X plus some number. Now, what you would do if you're in either one of these situations, the greater than situation, greater than or equal to situation, what you would do is you would shade above the line. So whatever half plane is on top, that's the one you shade. Now, if you're in one of these situations, you're going to shade below the line. Okay, so if I solve for Y, without actually plugging in any coordinates, I'll be able to know where to shade based on if I should be shading on top or on bottom, depending on if I solve for Y, how it looks. Or I could solve for X. And I would get something that looks kind of similar. So I would get either X is greater than some number times Y plus a constant, or X is greater than or equal to some number times Y plus a constant. Or I would get X is less than some number times Y plus a number, or X is less than or equal to some number times Y plus a number. In the first scenario, you would shade to the right of the line. And in the second scenario, you'd shade to the left. Okay, so that's a couple ways to actually determine where you want to shade. So you can actually plug in a random point of your choosing, and of course, when you're doing that, plug in an easy point, right? Don't plug in, oh, I'm going to plug in minus 0.736, comma 15.928. Like, no, pick whole numbers, nice numbers. They're easy to compute. A lot of times, I pick the origin, pick 0, 0. Plug that in. Does it make sense? If yes, we're good. If no, then no. We'd go the other way, right? So yeah. Otherwise, if you're not the plugin type, what you can do is you can solve for Y or X, and based on how it looks, you'll know, oh, I'm shading to the right, or I'm shading to the left, or I'm shading on top, or I'm shading on bottom, and you can know that way. So either way is fine. Just pick the one you like best and always do that. Now, the shaded region above represents the so-called graphical solution. That's the solution that you get from as a picture, right? And for us, the part of the thing that we're doing by hand, it's mostly going to be us finding graphical solutions for the most part. When we get to 5.3, we're going to leverage this graphical solution to finding non-graphical ones, to finding numerical solutions. Okay. So that's the graphical solution. It is the region of space that contains all points that solve the inequality. If you have dash, 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 the points on the line are not in the solution. If the points on the line are in the solution. Yeah, I think that's actually all the notes I want to give you here. So just to recap, okay? So we're talking about linear inequalities. We're talking about them in two variables, which we can sketch in 2D space. Anything that looks like this, cool. All right, what does it mean to find the solution of such a linear inequality? It means we want to find all points so that when we plug them in, we plug in X and Y into these guys, it makes a true statement. Okay, awesome. The solution is going to be a half plane. The reason why is because when you draw the picture of the linear inequality, it's going to be a line that splits space into two halves, and one of the halves is going to be the solution, right? Now you can graph this by graphing the line, making sure you're graphing a broken line if it's a strict inequality and a solid line if it's not. And you want to determine the half plane that has the solution. And you want to shade this half plane. And there are two main ways to actually do this. You can actually plug in a point to see if the inequality is true, pick a random point in one of the half planes, plug it into the inequality. If it makes sense, that half plane is a part of your solution. If it doesn't make sense, the other half plane is the solution. Then you shade that. You shade the one that gives you the solution. You could also rewrite something, or maybe sometimes the inequality is given to you in a form where it's already written like this, and you can determine, oh, I can shade above or below, or I can shade to the left or the right? The shaded region is called the graphical solution, and it's going to be very important for us to be able to find the graphical solution for our applications. So this is going to allow us to leverage a lot of computational efforts. Okay, so yeah, so that took a while, but that's pretty much all the theory we need to know for 5.1 actually. So now what we're going to do is we're going to do a few examples. Okay, here are some inequalities. We are going to sketch the solution of all of these guys. It's going to take some getting used to this. What I'm realizing now is like that this tablet, it's kind of like it's like a tablet. It's like a tablet, right? So the last tablet I had, it was more like a laptop in terms of how it functions. This one, actually, it feels more like a cell phone, the way it functions, you know? So most of the time, instead of right clicking or something like that, you would actually tap and hold and then wait for the right click to come up. And yeah, it's kind of weird. I have to get used to it. So, all right, let's Let's do this. Here's the first example. Y is strictly greater than 1. Okay, so let's see what we would do that. So what we're going to do is we're going to sketch first sketch y equals to 1. And again, with a broken line. Okay, so that is what we are going to do. So hopefully you know how to sketch y equals 1. So we're going to draw our axes. And of course, y equals 1 passes through 1 on the y-axis, and it's a horizontal line. Therefore, I'm going to these are the important things that they don't tell you. Making sounds with your mouth while you're drawing makes you do it better. Yeah, they don't tell you this. Like I'm the one who tells you that. I tell you that. Textbooks don't tell you that. Make sure when you're drawing the line, go. No one does that. Okay, but you actually draw it better if you do that. So that's the line. Now we need to find the solution. Remember, there are one of two options. So one, to find the solution, one, plug in a point. Plug in, say, 0, 0, for example, but it's actually a good example. So I look over here, here's the point 0, 0. I'm going to plug it in to the inequality. We get 0 is bigger than 1, right? Because I'm plugging in y equals 0. Now, that's not true. So that means the origin is not in the solution set, which means I should be shading the other half plane. So it turns out my solution is up here. It's above the line. Okay. So I picked, so this red line cuts space into two halves. There's a top half and a bottom half. I plug in a random point in the bottom half. Why? Because it's a nice point to plug in. It's 2 zeros. It's super easy for me to calculate. So I plugged in a random point into one of these halves. It did not make the inequality true. So I shaded the other half, right? That's one way to do it. Or two, since it is y greater than 1, this is, I mean, this means it's y is greater than 0 times x plus 1. So this has the form y is greater than dx plus e. Hopefully that's obvious. So I know I should shade above. Okay, which is what I ended up doing anyway. So either way I thought about it, I would have gotten to the right answer. Okay, so there are two ways to actually kind of think about that. Anyone have any questions so far? Are we good? Do we understand what's going on? Is anyone here?
I'm good, Professor.
Okay.
Yes.
All right. Steven is good. All right, so let's keep going. Here's another one. Okay, so here is another one. X less than or equal to 5. Same idea. I'm going to sketch these guys. These are my axes. So I'm going to sketch x equals 5, which hopefully you guys know that that's just a vertical line passing through 5 on the x. Now, couple ways to notice how to shade this. Because it's in the form x is less than something, then the solution is to the left. Right? So it's already in that form, right? So could since x is less than or equal to something, shade left. Or, like I said, you can plug in something. Plug in, say 0, 0. Right? So that's this guy right here. And what you would get 0 is less than or equal to 5. This is true. So 0, 0 is in the solution. Sketch the half plane containing, shade the half plane containing it. Right? Either way, you get that. I also want you to appreciate that here I drew a broken line because it was a strict inequality, whereas here I drew a solid line because it's possible to be equal. So it tells you here, note the points on the line are not in the solution. Maybe I should know that. Note. Note the points on the line are not in the solution. Whereas here, note the points on the line, so the line itself, are in the solution. Right? So that's why I drew it as an unbroken solid line, right? They're in the solution. Okay. That's that. Let's do another one. Okay. Okay, here's one that is a little more challenging because it's not, I haven't solved for the y or the x. So here's what we're going to do. And So obviously first we're going to need our axes. Okay. Now, how do we actually sketch this? So remember, you only need at most 2 points. Now, what are the points that we want to sketch? So note, to sketch this guy, 2x plus 2x. I'm going to plug in 2 points, and it's plugging in the intercepts. Plot 2 points. Because your A and B are not 0, the intercepts are actually really nice points to do here. Are both not actually, you need A, B, C are all not 0. So intercepts are convenient. So how do you plot the intercepts? So for the x-intercept, let me remind you, you are going to set y equals 0. So you're literally going to pretend that your y is 0. So you would, of course, have 2x equals 6, which means that your x equals 3. What do you do with that information? Well, you go on the x-axis and you plot x equals 3. Right? Then you go, I'm going to find the y-intercept. Set x equals 0. So you're going to get minus 3y equals 6. This would mean that y equals minus 2. So this here is your x-intercept. This here is your y-intercept. So I'm going to go to the y, and I'm going to plot minus 2. Now, let's find another point. No, we don't find another point because Jhevon told us you need at most 2 points. You start going finding other points, you are now wasting time. You're doing stuff you shouldn't be doing. So it turns out 2 points is enough to sketch a line. So now I'm going to sketch the line. Last class I did that. I didn't go through the points, and it's because I didn't make the sound with my mouth. Facts. Okay, so now we have the line. It's a solid line. Should it be solid? Yes, because it's less than or equal to, right? So now we just have to figure out which part contains a solution. So I will also mention you don't need to show this in your work. At this point, I'm going to assume finding intercepts is light breathing and is second nature to you. In fact, you don't even have to write it out for yourself. You could literally just like cover up one of the variables with your finger and then solve for the other one. So if I see this guy, cover up the 2x with my finger, I see, oh, minus 3y equals 6. That means y equals minus 2. Plot minus 2, done. Cover up the 3y with my finger, oh, 2x equals 6. That means x equals 3. Plot 3, done. Line, done, right? So this should be very quick. So we end up there. Now, what you can do is you can notice that I can solve for x and get x greater than or equal to something, which means I should be shading on the right. For example, I can add 3y to both sides, so I get 2x is greater than or equal to 6 plus 3y, which means I would get the x is greater than or equal to something when I divide through by a positive number, and so I should shade to the right. Another way to realize this is that if I were to plug in a point, say the origin, so I go here and I plug in 0, 0, If I plug this into the inequality, I would get 0 is greater than or equal to 6, which is not true, which again tells me I should shade to the right. So the solution is to the right. See, didn't make the sound in my mouth. Solution is there. Now, again, also notice note solving for x, which is probably the easier one to solve for in this situation. I would get x is greater than or equal to 6 plus 3y all over 2. So that tells me shade to the right. If I solve for y, okay, so now if I was solving for y, I'd probably move the y to the side that makes its coefficient positive. So I move the 6 to the other side. So I would get y is less than or equal to 2x minus 6 all over 3. So that tells me I should shade below, right? So if one person solves for x, they're going to say, oh, I should shade to the right. And if another person solves for y, they should say, oh, I should shade below. In either case, you're both going to shade the same part, right? The blue shaded region is to the right of the line. And if you look at it as splitting in top and bottom, it is to the bottom of the line. It is to the bottom right. The region you want is to the bottom right. So either way you do it, you can know where the answer is going to be. And the other one is going to be, well, you plug in a number, plug in 0, 0. If you plug in x equals 0 and y equals 0, you get 0 is greater than or equal to 6. This is obviously false, which means that 0, 0 cannot be in the solution, which means the other side is in the solution. And so you would shade that. Okay. So for the last two examples, I'm going to do, so I'm explaining a lot here just to make sure we understand. The others I'm going to do very quickly without writing everything out, kind of how I would expect you to do it on a test. And I guess pretty much as fast as I would expect you to be able to do it on a test as well. So yeah, at least as fast as sleep deprived Jhevon is how you need to be able to write this on a test. Okay, so here's another example, right? So what would we do here? Is that size? Okay. So here's another example. How are we going to do it? Well, first going to sketch my axes. Cover up the x with my finger, y equals 2. Cover up the y with my finger, x equals 2. Sketch the line. Oh, it's a strict inequality. Plug in the origin. I get 0 less than 2. Yeah, that works. Done, right? So at the end of the day, it shouldn't take you a long time. You should be able to actually do this relatively quickly, right? So from start to finish, if you're not on an annoying tablet, it's less than 10 seconds, you should be able to do this, right? And this is still with me actually talking what I'm doing because I want to make sure you guys get it. In 5.2, we're going to be having to do this with several things at the same time. So knowing how to do one of them fast is definitely to your benefit. because you're going to have to be doing several all at the same time and kind of finding where the overlapping region is, right? Which is what we call the feasible region. So I'm going to do this. Plugging in x equals 0, I get y equals 0. Plugging in y equals 0, I get x equals 0. I don't get 2 points. I actually get the origin. That's kind of weird. Okay, do I need to plot another point? Well, no, I would just notice that this is the same as x equals y. So that is just a line at 45 degrees going through the origin. Now, if I plug in x equals 1, y equals 0, that actually makes sense. So that's the answer. Equivalently, I could have solved for x. I would get x greater than y. X is bigger than means I shade to the right. Right, so that's actually passing through the origin here. So any questions on that? On the last two examples, especially because I didn't actually write everything out. So kind of did these rapid fire. Any questions, comments, concerns? Are we good? Are we bad? Are we alive?
We're good.
Okay.
Alive.
So make sure, because we're going to be doing this on steroids, because in 5.2, we're going to be doing several of these all on one picture and finding the overlapping ones. So you need to understand this and you need to be very quick at it. And then we're going to do it. And then in 5.3, just getting the picture isn't even solving the problem. You're going to have to do stuff after that. So yeah, hopefully you really get it. So what I will do is I will leave the examples for 5.2 up, and you guys can actually try it for Friday. It'll also be nice, I guess, if you tried it in your groups. In fact, I'll actually probably ask you guys to do it. Why do I have to do all the work? So I'll leave the 5.2 examples in the notes. And you guys can try it for next time. So pretty much you want the region that satisfies all inequalities at the same time. Right? That's what you want here. That's what's called the feasible region, by the way. And so, yeah, you're going to do that. You're going to sketch all these regions. You're going to find the region that satisfies. You're going to sketch all these inequalities. Find the region that satisfies all inequalities at the same time. And yeah, you want to be able to do this relatively quickly because it's not even going to be the start of the problem that we're interested in. It's actually going to just be the thing that gets us to start solving the problem. Okay, so yeah, try that for next time. We'll do these on Friday. Maybe we can start section 5.3 as well, but at least we'll get through 5.2. So definitely be able to try these, and we will stop there. So hopefully that was good. Sounds like it was good. No complaining. So I will assume that we're all great. So yeah, I guess that's it for today. I will see you guys in the next one. Ciao.